गुड मॉर्निंग एमएससी स्टूडेंट। माई सेल्फ डॉक्टर चंद्र प्रकाश गारू। हम डिस्कस करने जा रहे हैं ग्रुप थ्योरी एमएससी फाइनल ईयर। हम डिस्कस कर रहे थे एलिमेंट ऑफ सिमेट्री के बारे में, जिसके अंतर्गत हमने एक्सेस ऑफ सिमेट्री, प्लेन ऑफ सिमेट्री, ऑल्टरनेट एक्सेस ऑफ सिमेट्री, सेंटर ऑफ सिमेट्री के बारे में डिस्कस किया और कुछ एग्जाम्पल्स हमने डिस्कस किए। उसी कड़ी में हम डिस्कस कर रहे थे फॉस्फोरस पेंटाफ्लोराइड की सिमेट्री एलिमेंट्स और सिमेट्री ऑपरेशंस के बारे में। इन दिस मॉलिक्यूल ओनली टू ऑपरेशंस दैट आर S31 and S35 are new operations, while other coincident with axis of rotation, that is axis of symmetry, and plane of symmetry, that is sigma h. So S13 it is S31 sigma, new operation. S32 it is actually C32, coincident. S93 sigma h, coincident with each other. Some examples or some symmetry operations regarding alternate axis of symmetry are shown here, that which are new and which coincident with the other symmetry operation are shown here. Hexagonal bipyramidal. In hexagonal bipyramidal structure, the axis of symmetry is, principal axis of symmetry is C6 and C62 coincident with S62. In hexagonal bipyramidal structure, S62 and C62 coincided with each other and also coincident with S32, that is improper rotation axis of half fold. Improper rotation axis of half fold. Symmetry elements, this representation as mirror matrix, metric representation of the symmetry elements. Matrix can be defined as a regular array of numbers. In matrix, numbers are arranged in column and row. Result of symmetry operation can also be represented through matrices. Matrix of element having m rows and n columns can be represented as follow. You can see the matrix representation that has m rows and n columns. 3 by 3 matrix is shown here, in which first column has element A11, A21, A31. It is first column. In second column, A12, A22, A32 are shown. In third column, A13, A23 and A33 are shown. In first row, A11, A12, A13. In second row, A21, A22, A23 are shown. In third row, A31, A32, A33 are shown. Aij represents element of ith row and jth element represent element present on diagonal of matrix are termed as diagonal elements. Which are diagonal element in above matrix? It is A11, A22 and A33 are the diagonal elements which are present diagonal of the matrix. Ij, which it is represent element of ith row and jth column. Ith row and jth column. A11, what it represent? It is the element of first row and first column. What is the meaning of A22? It is the meaning that it is second row and second column. What is the meaning of A33? It means that third row, third column. What is the meaning of A23? It is second row and third column. What is the meaning of A31? It means it is the element of first row, it is the element of third row and first column. A32, it is the element of third row and second column. A23, it is the element of second row and third column. Thus, in this way, you can represent your symmetry operations in form of matrices. If all the diagonal element of matrix are 1 and other elements are 0, if diagonal element, if A11, A22, A33 is 1 and other elements like A12, A13 are 0, then such matrix is defined as unit matrix. It will be defined as unit matrix. Combination or multiplication of matrices. Combination or multiplication of matrices. Combination of two matrices that are shown here can only be performed when number of rows of the first matrix are equal to number of column of the second matrix. What it means? In given example, you can see that the first matrix, it is 2 by 2 matrix. It means it has 2 rows and 2 columns. In second matrix, it is also 2 by 2 matrix. It also has 2 column and 2 rows. And what is the combination? How you can perform multiplication or combination of two matrices? Combination of two matrices can only be performed when number of rows. In first matrix, it is row number of rows is 2. Of the first matrix are equal to number of columns in second matrix. It is same. First matrix has 2 rows and second matrix has 2 columns. Number of rows of first matrix are equal to number of columns of second matrix. In this case, multiplication of these two matrices or combination of two matrices can easily be performed, and it is shown in this example. In which way multiplication is performed? Now, the result will also, because it is 2 by 2, it is combination of 2 by 2 matrices. Therefore, result will also be 2 by 2 matrix. You can see that first element, which is first element, it is. Now we are going to discuss matrix representation of symmetry element of water. Identity operation in water does not result in change. Identity operation water does not result in change of coordinates. So its symmetry operation can be represented by following matrices. Following matrix. Which element or operation is represented? It is the identity operation of water. X, Y, Z's are coordinates, and it is denoted by unit matrix, that is diagonal element are 1 and non-diagonal elements are represented by 0. Therefore it is a unit matrix and it represents identity operation of water. Identity operations of water. X, Y, Z are shown. After performing identity operation over the coordinate X, Y, Z, there is no change at all. X, Y, Z are there before any operation and X, Y, Z's are there after performing identity operation. Identity means no change at all. The original structure is again obtained after operations. Then identity operation means no change in coordinates. X, Y, Z's are before the operation and X, Y, Z's are present after the operations. And the representation of matrix representation of this operation is unit matrix, that is diagonal elements are 1 and non-diagonal elements are 0. You know water has C2 element of symmetry or C2 operation is there. C21 first time rotation by 180 degree. In this molecular plane of water, the axis passing through oxygen, that is present in molecular plane. If rotation is carried out by an angle of 180 degree, you will get indistinguishable configuration. Therefore, water has C2 axis of symmetry. C2 one time rotation of 180 degree. What will happen? In this, as you know, the axis along which rotation is carried out, this axis is present, it is Z, it is present in Z direction. Then what happen? X and Y will be minus X and minus Y. X, Y, Z coordinates are there. After C21 operation, you will get minus X, minus Y and Z. Yani there is no change in Z direction, but coordinate X becomes minus X and coordinate Y becomes minus Y. Therefore, matrix representation of the diagonal element is minus 1, minus 1, 1. Minus 1, Y minus 1, X is minus X. Y minus 1 in middle diagonal element because Y is now minus Y. Z there is no change in Z, therefore it is 1 only. You can see sigma Vxz, sigma Vxz, sigma Vxz, that is the molecular plane itself. In this way, in xz plane, reflection if carried out, then there is no change in coordinate x and z, but y, there is a change in y. Y becomes minus y. Therefore, in matrix represent, you can see that 1, minus 1 and 1. You can see the diagonal elements, that is 1, minus 1 and 1. Why 1? Because there is no change in x coordinate. Why the second diagonal element is minus 1? Because there is a change in y coordinates to minus y. And there is no change in z coordinate. Therefore, the third diagonal element is shown by 1 only. If reflection is carried out in YZ plane, there will be no change in YZ coordinates, but the x coordinate will change. Therefore, x becomes minus x after reflection in sigma v YZ plane. Therefore, the first coordinate of matrix, first diagonal element of matrix become minus 1, while the second and third diagonal elements that represent y and z coordinates will remains 1 only. There is no change at all. Character of matrix we will discuss in next class.